Hey everyone, welcome to our very first lesson in the ratios unit. And I've just written in the first definition for us. You may have learned ratios a bit last year. This is kind of a review, and then we'll do some new things with them. So what is a ratio? It's a comparison of two values, and typically ends up being a fraction, which I know is not always our favorite topic, but we tend to use the fraction notation pretty often with these. So you can write in a comparison of two values or take note of that as its definition. So if you have two quantities, like 3 apples and 2 bananas, then we can write that a few different ways. We're going to use A and B as examples here, but A and B could be any single numbers possible. So what I'm actually going to do is, instead of using the letters, which can be a little confusing, one ratio might look like 3 to 2. You could also write that with words. The colon kind of represents 2, so 3:2 means 3 to 2. You can put the word 2 in there, or you could use the fraction 3/2. Even though fractions make things harder in some ways, they're going to be very useful for us pretty soon. Whenever we're dealing with any kind of ratio, we should always put it in simplest form. So you know with fractions, you shouldn't leave it as 2/4. You should make it equal to 1/2. So we want to make our ratios or fractions in simplest form all the time. So how do we do that? Let's do a very quick review, and then we'll do some problems. What you want to do is find the greatest common factor. Remember this back when you had fractions and you were trying to simplify them in last year's math class. We want to look for the biggest number that goes into both the numerator and denominator. So for all three of these, does any number go into both of them? In this case, no, but we'll look at some examples down below where they are. So we'll find the greatest common factor and just divide the top and bottom by that number. So 16/30 is not simplified. We want to know what's the biggest number that goes into them. You have to think for a minute. But 2 should, right? They're both even. And I can't think of a number that's bigger than that. So let me just start with 2 and see if that's good enough. So if I divide these each by 2, I'm going to get 16 divided by 2 is 8, and 30 divided by 2 is 15. And now I can look at 8/15 and say, do they share any numbers in common? And they don't. 8 has 2 and 4 that go into it, and 15 has 3 and 5. So we are done with that. You don't have to write the division sign in, but it can be helpful if you want to. So let's write this in simplest form, and the directions say to do it in 2 different ways. So let's just do it in all 3 ways just to practice, okay? Let's start with the fraction way, just to get used to using it, because that's the one we're probably going to use the most, so better to get used to it, right? So if I want to make a ratio, and I'm looking in my cabinet and looking at games that we have, what's our ratio of board games to video games? Well, it's 9 board games to 3 video games. But I look at 9 and 3 and say, they both have a number in common. 3 can go into both of them. So if I divide each of those by 3, I'm going to get 3/1, which technically is an integer. That technically equals just 3. But ratios have to be written as a fraction. You can't get rid of that 1 in the bottom. We can also write that more simply as 3/1 or 3/1. I don't know why all my 1s look different. So we could write it this way, or this way. All 3 of those are different ways of writing ratios. Let's look at a problem like number 2. I'm going to show you a trick with number 2. So if you're looking at say the 10th grade, and we don't have football at Burke, but pretend that we did, and there were 18 soccer players in the 10th grade and 30 football players. What's the ratio of one to the other? So let's start with a fraction. And we do the numbers in order, by the way. Because 18 comes first, the 18 should be on the top. Here's a trick. You're looking at 18 and 30, and you're trying to figure out what the biggest number is that goes into each of them. The answer is 6. But what if you didn't realize that? Maybe the numbers are awkward and you're not sure how to work with them. I look at 18 and 30 and I say, I know that 2 goes into each of them. Let me just try dividing by 2. This will give me 9/15. 18 divided by 2 is 9, 30 divided by 2 is 15. Then I can ask, well, what number goes into 9 and 15? I know 3 goes into both of those. So let me divide each by 3, and that will give me 3 over 5. If I had just divided 18 by 6 and 30 by 6, I could just skip this middle step altogether. But sometimes looking at a problem, you might not immediately know the greatest common factor, and there is nothing wrong with taking more than one step to get there. So here I started by dividing by 2, my numbers got a lot smaller, then I could see that 3 went into both of them as well. This might be a silly example to show that on, but it might help with another example a different day. And so here are all the different ways I could write that ratio. Let's look at one more example like that to kind of bring that home. We're doing a bake sale, and we end up with 75 cupcakes and 15 cookies. How do we write that as a ratio? It's a lot of cupcakes, first of all. 75 over 15. You may not know what numbers go into 75. I do, but I'm a math teacher, and I do this a lot. But what number do you know definitely goes into both? You should look at this and say, oh, I know 5 would go into both because they both end in 5. So let me divide both numbers by 5. If you need to grab a calculator, you can. 75 divided by 5 turns out is 15. Maybe you knew that. Maybe you don't. I don't know. What's 15 divided by 5? That's 3. Now our numbers are a lot smaller. Now let me look at 15 and 3. Are there any numbers besides 1 that go into both of those? And yeah, 3 goes into 15, and 3 goes into 3. So that becomes 5 over 1, which is 5 to 1 this way, or 5 to 1 that way. And again, if you recognized here that 15 goes into 15, and 15 goes into 75, that's awesome. You could just skip this middle step and get right to the answer. So I just wanted to show you that as a trick. Sometimes going for perfection can be tough, but getting any step forward is a really good way to do that. Let's just do one application problem to show you that word problems here are not that scary. Let's look at the longest one, number 11. It's a long story here. Miss Morgan is the cafeteria manager. She keeps track of how many students select each type of drink. It's a very exciting job. Today during breakfast, 32 children picked milk, and 44 children picked juice. What is the ratio of the number of children who picked juice to those who picked milk? This one is tricky because of the order. The ratio of juice to milk means that we're going to look at the juice number on top and the milk number underneath. So what is the juice number? 44 kids picked juice, and who picked milk? 32 children picked milk. Now we have to simplify that. You may not know that 4 goes into both of those. Maybe you do, and that would be great. But suppose you didn't know, you can just divide both by 2. You get 22 over 16. And you say, uh-oh, those are both even again. I can divide them by 2 again, and I get 11 over 8. We do not do mixed numbers here. We do not do 1 and 3/8 here. We will leave it as 11 over 8. Or we could say 11 to 8 or 11 to 8. All of those are appropriate answers. So word problems, helpful techniques. You can underline important phrases. You can underline important numbers. But when you're dealing with ratios, the order does matter. Juice to milk. So juice comes first and milk comes second. And then always simplify your answers. And so that's the basics of working with ratios. We'll do a little bit more with applications with them and calculations pretty soon.